Hello friends, this is from Veda Tutorials, Dharwad. As usual, I am Lakshmi Kusoji. So in previous session, we discussed about the real numbers, means some basic parts of the number system. So today, I think you understood that all the basic points in the previous sessions. So today, I am continuing that chapter only, real numbers chapter only. So in this chapter, we are going to learn 2 points. Mainly there are 2 points. So let's start the class. Okay. Note down the points. In this chapter we are going to learn 2 points. Those are Euclid's division algorithm and the fundamental theorem of arithmetic. Okay, these are the two main points we are going to learn this chapter. So see here, Euclid's division lemma. What is the theorem of the Euclid's division lemma? What it says? So the Euclid's division lemma says here, a and b are two given positive integers. Here a and b. So any numbers, any two positive integers you take here. So a and b are two given positive integers. There exist, so listen here, there exist unique integer q and r. Means a and b are two given positive integers. Okay, so these are the two positive integers, but in that there exist one unique integer. There are two unique integers are exist. What are those? Q and r. Q and r. So these satisfying, so whatever this a, b, q and r, these all numbers are there na, integers are there na, these are satisfying. What they are satisfying? A is equal to b into q plus r. So this is the main formula here. So whatever Euclid's division algorithm we are going to learn, na, this is based on this formula only, based on this theorem only. So what it says? A is equal to, what it satisfies? A is equal to b into q plus r. And next see, 0 is smaller and equal to r, and r is smaller than b. So I'll tell you one easiest method here. So in your from second standard, from third standard onwards, I think you learnt divisions. So based on these divisions only, we have seen, means when we verify that our division is correct or wrong, that time we use one formula. So what is that formula? Dividend. Okay, dividend is equal to divisor into quotient plus remainder. So you have seen this one. I think you have learnt this one. From third standard onwards only you learnt this one. When we are verifying our division is correct or wrong, that time we use dividend is equal to divisor into quotient plus remainder. See here one example. I'll take one easiest example here. So now 32 is divisible by 2. The 32 is divisible by 2 means how to do this one? 2 ones are 2. 3 minus 2 is 1. You are taking 2 here. 2 6 are 12. Now see here. This 0 is called here remainder. This 0 is called here remainder. And 16 is called here quotient. You know this one. And this one is divisor. This is what here? This is divisor. And 32 is dividend. Correct? The 32 is dividend. So this formula only here they applied. Okay. This formula only here they applied. Means A means here dividend. B means here divisor. Quotient plus remainder. So already you know 0 is smaller than equal to what? 0. 0 is smaller than equal to remainder. Sometimes it is equal to 0. Now we got 0 here, or sometimes smaller than also we get, like 1, 2, like that, whatever the divisor they given, smaller than that we get. Okay, last is b. B means what here? That is what? B means what here? Divisor. That is divisors. Remainder is always smaller than b also. Is it? So it satisfies this one. So this is the Euclid's division lemma. Now let's see the next point, that is fundamental theorem of arithmetic. So next whatever the next point is there, that is the fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic says? Very easiest part this one. Already in our previous session we seen some prime numbers and composite numbers. So this is based on this only. The fundamental theorem of arithmetic is based on this only. You know the prime numbers, prime factors, means it is very easy to find this one. Okay, now see what it says. Every composite number, means whatever they given, that number like 24, 64, 3286, these numbers are called here composite numbers. So every composite number can be expressed, these numbers are expressed as a product of primes. You get some product of primes when you take the 24. What is the product of 24 here? Means what are the primes of the 24, prime numbers of the 24? So 2 1s are 2, 2 1s are 2, 2 2s are 4, 12. Okay, next 12 is divided by, again you know that one, 12 is divided by 2 6s are 12, 2 again 6 is divided by 2 3s are 6. So last we got, means here how many times you got here? See, 2 2 2 and into 3. So 2 into 2 into 2 into 2. So these all are prime numbers, means can be expressed as a product of primes. It is expressed as a product of primes. Product of primes, see, 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 3s are 24. Yes. So as a product of primes, and its factorization is unique. Whatever you did now, this factorization is very unique apart from order in which the prime factors occur. So leaving these prime numbers occur, whatever the prime numbers are occurs. So this is very unique part. I think you understood. So what the fundamental theorem of arithmetic says here, every composite number can be expressed as a product of primes, and its factorization is unique. Whatever you do now here, this factorization is unique apart from order in which the prime factors occur. You don't worry about the order. Sometimes we take 3 also because it divisible by 3 table also. 3 8s are 24. Correct? 24. We started by 3 also. Sometimes we started by other number also. You don't worry about the order of the factors, but you see how many times the prime numbers are occurred here. Okay. Now see, for any two positive integers, here also they given two positive integers, they given a and b. Any two positive integers a and b. So what is the fundamental theorem says here? HCF of a and b. HCF of a and b into LCM of A and B. In your previous years, in previous classes, you studied how to find the HCF. HCF means highest common factor, and you know how to find the LCM. That also you learned. Lowest common multiple, least common multiple. You know that one. HCF of A and B and HCF of A and B into LCM of A and B is equal to the given two integers, the product of two integers A into B. So this is the fundamental theorem of arithmetic. Now again here using this formula, again we write two more formulas. So those are, now see here, what are that two more formulas? HCF of A and B. If you are finding the HCF of two numbers, that time A into B, the product of these two integers, divided by LCM of A and B. So sometimes they give A and B, two integers, and LCM you find out that one, and you find out the HCF. Sometimes they give LCM only, and A into B they give, you find the HCF. LCM of A and B is equal to A into B of a HCF of A and B. So these two formulas are also important. Okay, this much Euclid's division algorithm and fundamental theorem of arithmetic theorems are you understood. Now let's start some important questions. Here one question is there. Let's see what is that question. Note down the question. Find the HCF of 135 and 225 by using, see, listen here, They only given by using Euclid's division algorithm. You find here the HCF of 135 and 225. So which method to use here? So use here Euclid's division algorithm. Okay, note down the question and with me only you start the solution. It helps you revise your lesson. You revise your question. Okay, let's start the solution. Now see. Solution. See here, the two numbers are given here. So what are the numbers here? 135 and 225. 135 and 225. So 135 is the smaller than 225. Is it right? 135 is smaller than 225. So then you apply the Euclid's division algorithm or Euclid's division lemma. That theorem you apply. So let's start here. So what the Euclid's division lemma says here? What is the formula of that? First you note down the formula. A is equal to B into Q plus R. So this is our Euclid's division lemma formula. So using this formula, let's start. I'll do some rough work also. I think it is visible for you. Okay. Now see. So 225 is divisible by 135 because 225 is greater than 135. Na? You take 225 is divisible by 135 means 225 is equal to. Now see, I'll do here some rough work. 225 directly I don't write here answer, otherwise you don't understand. 225 is divisible by 135. So 135 ones are 135, 135 twos are 270. So 270 is more than 225. So that's what I take. 135 ones are 135. So what is the remainder here? 0. What is the remainder? Tell me. Yeah, this one is 90. The remainder is 90. So what is the quotient here? 1. So how to write this one here? How to write this one here? B. B means what here? B means that is 135. We divisible by B na? Means this one na? So 135. What is the quotient? 135 ones are 135. What is the remainder? 90. Okay. So this much. Now see here. 90. We got the remainder 90. We got the remainder 90. But 90 is here not equal to 0. Correct? The 90 is not equal to 0. The 90 is not equal to 0 means what to do? Again you continue the same process. Now you take 135. So you got the remainder 90. Using 90 table, you divide it. Which table? 90 table. So again I'll do here some rough work. 135 is divisible by 90. 91 is a 90, 92 is a 180. Means 9 table. 9 2 is a 18, 180. So not goes 91 is a 90 only will take. So again you subtract it. What is the remainder of this? 5. 13 less 9 means 4. 45 is the remainder. So 91 is a 90 quotient plus 45. Again you see here. Again here we got 45. The remainder we got 45. So 45 is again is not equal to 0. Means still you continue. So what to continue? 90 you take. This number you take is equal to, it is divisible by 45 table. Remainder. So it is very easy. 45 ones are 45. Directly I'll do 45 ones are 45. 45 twos are 90. 45 twos are 90. What is the remainder? 45 twos are 90. Otherwise I'll do here. See. 45 ones are 45. 45 twos are 90. 0 is the remainder. Means 0 is the remainder. So what we got here? The remainder we got, that is 0. The remainder is 0. So hence, therefore, HCF of 135 and 225 is what? 45. This number you should take. Whatever the last remainder you got, na? Whatever the, here, this step, whatever the last is there, na? This one you take. This is the HCF. This is the HCF of 135 and 225. So this is the almost 2 mark question. These questions about the 2 mark questions only. I think you noted this one. Next, I'll take here one more question is there, same like this only. So that question is asked in your previous year. That question is asked, occurred in the previous year 2023 March. 2 mark question, that is. See here, what is that question? Find the HCF of 72 and 120 by using Euclid's division algorithm. Same, it is also same only. So I think you noted the question. I'll repeat the question. Find the HCF of 72 and 120 by using Euclid's division algorithm. This is occurred 2023 March. 2 marks question. So when you just see the question paper, 2023 March question paper, you see in question number 3, third main is there. In that first, maybe series wise is there, but I think which series I don't know. But in that series, the first question only, this one is asked. Okay. Now let's start the solution. Let's start, student, the solution of this question. Okay. So here also you see solution. So in that solution, is it visible now? Okay. Here also 72 is smaller than 120. 72 is smaller than 120. So therefore, using same Euclid's division algorithm, that lemma theorem only use, A is equal to, what is that? A is equal to B into Q plus R. So this is the theorem of that, Euclid's division theorem of that. So here you take 120. 120 is bigger, na? So V divisible by 72 table. 72, how much? Directly you know, directly also you do. Otherwise, I will do some rough work also. 72 table. 72 ones are 72. 72 twos are, you know, it comes more. So 144 like that. No, 144 like that. So 72 ones are 72 only I'll take. So minus it. What is the remainder of that? Yeah, 8. 12 less 8 means 4. 48. The 48 is the remainder. Means 72 ones are 72 and 48 is the remainder. So here you see the remainder is not equal to 0. So what is that? 48 is not equal to 0. The remainder is not equal to 0 means again you have to continue. Now you take 72 and it is divisible by 48. Again it 48 ones are 48 only it goes. 48 ones are 48. What is the remainder of that? 72 less 48 you do. That is 24. Correct? So again here 48 is 24 is not equal to 0. Whatever the remainder is there. Now 48 you take, again it is divisible by 24 table. Yeah, it goes, I think 24 twos are 48. So remainder we get 0. So the only 3 steps are there here. Only 3 steps are there. So therefore remainder is 0. So therefore, what is the HCF of this? Yes, you are right. The HCF is 24. Therefore, you write last point also. It has half marks. The HCF of 72 and 120 is what? 24. Yes. See, student. They will ask like this questions. Okay. So, today's class, I'll stop here only. Whatever important points are there, let's discuss next class. Thank you. And one more thing, please like our videos, share and subscribe our channel. So it motivates us to do more like these classes. Thank you.